Good morning, everyone. In this section, we're going to look at 9.1 and 9.2. This is Math 21, Introduction to Stats at College of the Sequoias. We've done the video lecture for 9.1 and 9.2. And we want to go over some problems in MATLAB, just to show you how they work. I'm going to go over 9.1, number 1, 2, 3, and 6. And we'll just get going here. So let me do a similar question. Okay, so compute the critical z-score. Compute the critical value for the z alpha over 2 that corresponds to an 84% level of confidence. Okay, alpha here is our level of confidence. So that's what the alpha is. Now, normally in the back in the days, we would figure out what that meant and plug it in, look it up on the table. We don't need to do that. We've got StatCrunch. So you can go question help StatCrunch, or I've already got the window loaded. What we want to do, it's asking us to do the area to the right if we have alpha percent in the middle. So my problem is saying 84% in the middle. I'm going to come over to StatCrunch, and I'm going to assume a normal distribution. I'm going to do stats, calculators, normal. Why can I assume normal? They gave us, they said it's a z-score. Z-score means normal distribution. Not only does it mean normal, it means standard normal. A mean of 0, standard deviation of 1. Now, if we have alpha percent in the middle, I'm going to click on between. And I'm going to put 0.84 where I want that in between. All they're asking me in this problem is what my z-score is. My z-score is 1.4051. That's all they wanted. To 2 decimal places, that's 1.41. That's it. That's all they want on number 1. If you don't know what z alpha over 2 is, it's a little tricky. And they show these links to the standard normal distribution table, which make it a little bit confusing. But all you got to do is stats, calculators, normal, do between, and it'll give you the alpha score that you need. Let's take a look at number 2. Let's see, number 2. So they want us to determine the point estimate of the population proportion, the margin of error for the following confidence interval, and the number of individuals in the sample with the specified characteristic X for the sample size provided. They give me a lower limit or lower bound. Lower bound and lower limit are the same thing, 0.392, and an upper limit of 0.828. They tell me N is 1500. Okay, and first off, they want us to find the point estimate. The point estimate is P hat. That's our point estimate. And the way confidence intervals work is point estimate is smack dab in the middle. Where did that phrase come from? That's a weird phrase. Smack dab in the middle of the lower limit and upper limit. So if I've got a number line here, and I've got 0.392 over here, 0.828 over here, my P hat is right here, right dead in the middle. One way of finding that is we're trying to find the average of these two numbers. What we can do is we can add these two together. I'll add 0.392 to 0.828. And I'll divide by 2. I can't see it at the angle I'm looking at, but if I look at my computer screen, I can see it. That's crazy. That's what I need. And then I've got that's the numerator. So this is 1.22 over 2. And now I can divide by 2. And I get 0.61. That's my point estimate. Round to the nearest thousandths, we don't need it. We just need the nearest hundred. Okay. The margin of error, so this is 0.61. The margin of error, if you recall, is the distance between the point estimate and the lower limit, or the point estimate and the upper limit. So I can find the margin of error just by doing the upper limit minus p hat. My margin of error is 0.218. It says the number in the of the individuals in the sample with the characteristic round to the nearest integer. Okay, so remember for proportions, p hat is x over n. And we know n was given to us as 1500. We don't know what x is. Well, we do know p hat is 0.61. This is an algebra equation multiplied by n to get x by itself. I'll multiply both sides by 1500. That takes away the 1500 on the left. And 1500 times 0.61 is 915. I have some odd friends. My friend just went to Costco and I asked him if he said the lines were quick and it was well organized. I said, did they have toilet paper? And that was his response. You just said it. I stopped wiping. I've got some crazy friends. That was number 2. That's all we needed. That's all they wanted. So calculate p hat, find the margin of error. It's the distance between the two. And then set up this little algebra equation and you're good to go. What is this? Interesting. Oh, it's the Zoom screen. I zoomed in a little bit. It allows me to position where I want to zoom at. Interesting. I don't know if you can see the little yellow square. It's on my screen. All right, so let's take a look at number 3. (9.1), number 3. Let's see what we got going on here. Construct a 90% confidence interval. Confidence interval, I use CI. It's not a criminal informant, it's a confidence interval. They're giving me x equals 180 and n equals 300. We don't need that value of critical values unless they ask us the second part. All we need to do is go into StatCrunch here. StatCrunch sets this up really easy. We're going to go stats, proportion stats. We're going to do one sample with summary. Oh, what happened? I screwed up resizing it. Oh well, won't do that again. There we go. Let's resize that one. So stats, we're going to go proportion stats, one sample with summary. X is our number of successes. And that's one of the boxes they ask us about. And N is the number of observations, which is your total in your sample. So they gave me 180 and 300. Hypothesis testing we're doing in the future. For now, we're just doing confidence interval. And they asked me to do 90%. I need to convert that to a decimal. So 90% switches down to 0.90. We shift the decimal point left twice. You want to leave it on standard walled. Switching to the other one is, it's not an introductory level stats concept. We're going to click it, and they give us the lower limit and upper limit. So I'm going to write them down. I don't know how many decimal places they wanted. Lower limit was 0.55347651. Upper limit is 0.646. My mouse is in the way. 52349. They want 3 decimal places, so the lower bound or lower limit is 0.553. My upper bound, 0.646, and the 5 says round that up to a 7. So 0.647. Of course, you're going to have different numbers. That was it. Let's see how easy that problem is. So whatever confidence interval they give you, go in and go stats, proportion stats, one sample. When they give you the number of successes and N, you're just going to do with summary. You type it in and it spits out the answer. There's little work here. Very little work here. Okay, I want to take a look at number 6, because number 6 is a little tricky. So a researcher wants to estimate the percentage of adults who support abolishing the penny. What size sample should be obtained if he wishes to be the estimate to be within 4 percentage points? So estimate to be 4 percentage points. They want a 90% confidence interval. In part A, they say use a previous estimate of for me is 38%. I don't know if you'll have 4% or not. What we're going to do here, so your command structure for this one, we're going to go, again, stats, proportion stats in one sample. But when they're asking what size sample, we don't know n. So that's what we need to compute. The way to do that is click on Power Sample Size. Okay, so I'm going to go Stats, Proportion Stats, one sample, Power Sample Size. You want to click on the confidence interval width tab if it's not selected, because that's what we're looking at for. We're looking at confidence interval right now. Click on confidence interval width tab. And it wasn't selected. So here I am here. We need to enter our confidence level. For me, that's 90%. Our target proportion is p hat. For me, that's 0.38. Now we need sample size, so width is the other box we need to change. It says required parameters, we have to have these values. Here we enter one. We either enter the width and it gives us sample size, or we enter the sample size and it gives us the width. The width is 2 times the margin of error. That 4%, how did they word it exactly? Estimate needs to be within 4 percentage points. Within 4 percentage points means they can go 4% either way. This is our margin of error. So the width, that's 0.04. The width is 2 times that, is 0.08. So I'm going to change my width to 0.08. Click compute, and it spits out the sample size. And out pops sample size. So for part A, I need to do 399. It does tell us to round up, but 399 is already an integer, so I don't need to do anything. And then it says B, no prior estimates. To work with that, we change p hat to be 0.5. 50% maximizes the error. If when p hat's 50%, it gives us the best number, or the biggest number that we'll possibly need. Oops. So I'm going to change my target proportion to 50. I'm going to reset width. I don't want to use that 799 they got. I want to set it back to 0.08. And I'll click sample size, and here they give me 423. So this one was 399. So enter in that, reset the width, compute, and I get n equals 423. . And that's how a lot of most of 9.1 is. You're either computing sample size, you're computing the confidence interval, the lower limit and the upper limit, and things like that. Okay. So I'm going to close 9.1. I want to take a look at 9.2 as well. Oh, good. It's still working. Pearson says MATLAB is down, but it doesn't seem to be down. So I'm allowed to continue working. So let's take a look at number 1, 2, and 3, and 6 again. Ooh. So here we are, we're in 9.2. This is number 1. Find the t value. This is similar to a problem we did yesterday in our practice. Find t so that the area to the right is 0.025 and degrees of freedom, which is df, is 8. We're going to go into StatCrunch. We're going to do stats, t-stats, and we're going to do one sample, and we've got summary. Oh, wait. We're calculating t. My bad. This is stats calculator t. Stats calculator t, they give me my degrees of freedom are 8. They want the area to the right, so I want to do greater than, so it's shaded red on the right. And I just need to enter in the target area that they said. 0.25 was mine. And so enter df. We're going to do probability that x is greater than or equal to blank equals 0.025. And for me, it spits out 2.3060041. I don't know how many decimal places it needs, so I'm writing it all down. Again, this was stats calculators t. Let's go take a look at how many decimal places they wanted. 3 decimal places is 2.306. And now they want to do the area to the right. 9, okay, so part B, let me write it down. So I want 0.02 area to the right again. And df is 9. We're going to do the same thing. Stats, calculator, t. I'm going to set my degrees of freedom to what they're specified. I'm going to do greater than. I'm going to set that to 0.02. And this gives me 2.398441. I bet they want 3 decimal places again. Ta-da! On part C, they switch it up a little bit. They say area to the left. That hint, use symmetry, is if you're using the tables. We don't need that. We're doing StatCrunch. You don't need to use that hint. It's only when you're using tables. Left is 0.15. Degrees of freedom is still 9. I'll go back into StatCrunch. I want the area to the left. I'll make it left. And I just change this to 0.15. The reason why they say use symmetry is you can do, the table only shows to the right. If you're using the table, pretend you're doing to the right and switch it to the left. X is less than or equal to something here is 0.15. And it's a negative number. It's going to be important to use the negative. So the 7 rounds it up to 0, rounds that, or 10, rounds that up to a 10, negative 1.100. It should require the final 2 decimal places also, or the 2 zeros, because that's part of the rounded value. Find the critical value t that corresponds to 60% confidence. Assume n equals 24. Not n, degrees of freedom is 24. And we want 60% confidence. This means we're going to do between and do 60%. So we'll say probability because confidence interval represents the area, the middle area, and we want degrees of freedom was 24, it said, and 0.6. And notice the values are the same. They should be. That's the symmetry part they were talking about. Not sure what they're going to, how many decimal places that they're going to ask for, but that's what we're doing. Click on between. This is when we're doing the confidence interval portion. We're going to use the positive version. And this is going to round to 0.857. So that's number 1. Let's take a look at number 2. So it says the data from a simple random sample with 25 observations, it tells me n equals 25, was used to construct the plots given below. The normal probability plot that was constructed has a correlation coefficient of 0.949. Judge whether a t-interval could be constructed using the data in the sample. So what we need is the correlation statistic. We talked about this in lecture. The correlation statistic has to be greater than the critical value, which is based on n. And we need no outliers on the box plot. So let's just take a look at what they gave us. There's a lot going on there. The graph doesn't help us. The critical value is what, or the correlation value is what we needed. Look at that though, there's an outlier. There's an outlier. So I already know there's an outlier. what is N, or our critical value for 25? We go to our critical values table. And for N equals 25, the critical value is 0.959, which means R, which is 0.949, is less than our critical value, which was bad. We wanted it the other way. So we actually can't do a t-distribution on this. So it says the normal probability plot does not suggest the data could come from a normal population because we can't use it. We don't think it's normal because it doesn't meet the criteria. Because 0.949 is less than 0.959, and the box plot does show outliers. So a t-interval could not be constructed. So they try to trick it up here on this question. A lot of times, you ever notice they always are showing you where it does work? This time it doesn't work. We can't do it. Check my answer. Fantastic. Let's take a look at number 3. They give me lower bound is 16, upper bound is 28. They say determine the point estimate. We want p hat, and we want the margin of error. Remember, p hat is always directly between the lower limit and upper limit. So I can add the two. I'll take the average of them, 16 plus 28 over 2. 30, 46. This is 44 over 2, which is 22. And the margin of error, if you recall, is the distance between here and here, and here and here. So I can either do 28 minus 22, that'll find the distance from here to here, or I can do 22 minus 16, which will give me the distance from here to here. They both give me the same answer of 6. That's it. Let's take a look at number 6. See, this one's another one just like it. I think number 6 had a sample size one. Oh no, this was a recent one. So a trade magazine routinely checks the drive-through service times of fast food restaurants. An 80% confidence interval that results from examining 616, that tells me N, customers in one fast food chain drive-through has a lower limit, lower bound of 170.2 seconds and an upper limit of 173.6 seconds. What does this mean? So they're asking what does that confidence really means? So let's go through and reason them out. Number 1 can be, all of these should be 80% confident or 80% probability, something like that. 1 can be 80% confident that the mean drive time service time of this fast food chain is an exact number of seconds. That's not how confidence interval works. What a confidence interval tells us is how confident we are that the actual mean is between a specific set of values. It doesn't tell us probability. It doesn't say anything like that. It tells us that our confidence that the actual true mean time is between the lower limit and the upper limit. We need to find the one that says that. B says one can be blank confident that the mean drive-through service time of this fast food chain is between blank seconds and blank seconds. That one sounds right. It sounds right. So I'm going to check B, but I'm going to read C and D just to make sure. There is a blank % probability. That's not what confidence intervals tell us. They don't tell us probability. So that one's out. D, the mean drive-through service time of this fast food chain is blank seconds per certain percentage of the time. That's also not confidence interval. It doesn't tell us that. It doesn't tell us how often it has that kind of thing. It tells us a range and how likely our answer is in it. So we're going to go with this one. They actually ask us for the percentage, not the decimal. So we're going to leave it as 80%. And we're just going to type in the limits that they give us. 170.2 and 173.6. That's it. That's just asking you if you understand how it works. We can reason through number 7 real quick, and then I'm done. You got to do some homework. In a survey conducted by the Gallup organization, 1,100 adult Americans, that's our sample size, were asked how many hours they worked in the previous week. Based on the result, a 95% confidence interval for the mean number of hours worked was 42.77 to 44.5. How can we decrease the margin of error? So let's just go through them and talk about them. If we increase the confidence level, we're saying we're more confident, which means our picture, I need another piece of paper to reason through these visually. So A, increase confidence. So we've got 95% like this. If we increase the confidence level, this goes up. We get wider. And if we're getting wider, this distance right here from the lower bound to the p hat is our E. If I increase the confidence thing, it's getting wider. So that's out. B, decrease the standard deviation. Well, standard deviation is the amount of spread that we have. If we decrease it, if a high deviation means it's spread out more, a low deviation means it's spread out less. This should narrow down our bell curve, which would make the margin of error shorter. That looks like a win. Decrease the sample size. Well, do you remember what we had for sigma here? 1 second. How do we have sigma with mean? Sigma was sigma of the population over the square root of n. So if we decrease the sample size, this number on the bottom gets smaller. This gets smaller, which means sigma x gets bigger. That doesn't help. So C is out. D, decrease the confidence level. We're at 95%. If we decrease it, we're coming inward. That should narrow it down. That should decrease the margin of error. I've already got 2, so I just want to look at the rest. E, if I increase the sample size, again, sigma population over square root of n. If I increase n, this gets bigger. So like rather than dividing by 1, I'm dividing by 10. This means sigma x gets smaller. So we're decreasing the standard deviation again. That should narrow it as well. And the degrees of freedom don't affect the confidence interval like that. That's just finding the t-score. So we're at a little dilemma. It says provide 2. And I've got decrease the standard deviation of hours worked. Should do it. That might be the one they're eliminating though. Let's see. All 3 work. Let's just see what it says. Yeah, it's S. S is the sample standard deviation. It's divided by the square root of n. Are they wanting me to do that one? Yeah. B kind of combined. B and E were pretty much the same. Increase the sample size, decrease the standard deviation of hours worked. That should have still worked as well. I think they made a mistake here. So they're looking for the confidence level 1 and increase the sample size on number 7. And that gives you some practice examples on 9.1 and 9.2 in the homework. And we'll have class available for Q&A this week. I'll be logged into Zoom on the Confer Zoom in your Canvas tab. Please come visit and ask questions. Please watch the videos first though. Make sure you know how to do this stuff. Okay? Peace.